Hi everyone, welcome back to Made Everything Official. Lighter Machina operates advanced industrial production lines that manufacture precision components using automated casting and machining processes. The sequence begins with raw material preparation, where aluminum ingots are sorted and loaded into a heated feed hopper. The automated material handling system transfers the ingots into the induction melting furnace, where they are heated to a precise melt temperature under controlled conditions. Operators monitor the furnace parameters from a digital control panel to ensure uniform melt quality. Molten aluminum flows through a filtration unit to remove impurities before being directed into a high-speed die casting machine. The die casting machine's mold closes under hydraulic pressure, and an injection ram forces the molten metal into the cavity with exact timing and pressure. This ensures that each casting fills completely and minimizes defects. Once solidified, the die opens and robotic arms extract the newly formed parts onto the conveyor. As the cast parts progress down the line, they enter a series of automated trimming stations. At these stations, excess flash and sprues are mechanically removed using precision cutters and pneumatic actuators. Sensors verify the part dimensions in real time, triggering adjustments to the tooling if deviation is detected. After machining, the components proceed to the grinding and finishing stage, where dimensional accuracy and surface quality are refined. Automated grinding machines use abrasive wheels to remove minor tool marks, burrs, and excess material left from previous operations. The grinding pressure and feed rate are carefully controlled to achieve a uniform surface without altering critical tolerances. In areas requiring higher precision, operators apply fine manual polishing to smooth edges and transitions. This stage ensures consistent geometry, improves surface integrity, and prepares each part for final inspection and assembly. Each phase in this production line integrates automation, real-time control systems, and precision tooling to maintain consistent product quality and high throughput. Next, the cast components are transferred to a multi-axis CNC machining cell. Here, cutting tools perform drilling, milling, and contouring operations according to programmed tool paths. The CNC machines use high-speed spindles and coolant delivery to maintain cutting accuracy and surface finish. Automated tool changers ensure that the correct cutter is deployed for each operation without stopping the production flow. After machining, the parts move into surface treatment. A shot blasting station uniformly cleans and prepares the surfaces to remove oxide and enhance texture. Following this, a precision quality inspection system employs optical scanners and coordinate measuring machines to verify critical dimensions against design specifications. Parts that pass inspection continue forward, while any outliers are diverted for rework. Finally, the finished components enter the packaging section. Conveyors align the parts into trays, where automated labeling and protective inserts are applied. Workers perform final visual checks before the completed products are boxed and moved to the staging area for shipment. Alumina Industry operates a fully automated aluminum die casting foundry, specializing in high-precision cast components for industrial applications. The process begins with the selection and preparation of aluminum alloy billets, which are weighed and fed into the induction melting furnace. The furnace brings the metal to a precise molten state under tightly controlled temperature, ensuring consistent fluidity for casting. The injection system then takes over, forcing the molten aluminum into the steel die cavity at high pressure. This high-pressure injection ensures that the metal completely fills intricate mold details, creating accurate reproduction of the design geometry. After a brief solidification period under pressure, the die opens and the freshly cast part is ejected onto the conveyor. Each cycle's parameters, including pressure and temperature, are recorded for quality traceability. Conveyors carry castings to the trimming station, where automated presses remove flash and excess material. Precision trimming tools shear off burrs along predefined parting lines to prepare the casting for finishing. Next, parts are routed through mechanical finishing cells. Here, mechanized grinders and brushes refine surfaces and smooth transition areas, preparing the casting for dimensional inspection. Finally, approved components are staged for packaging. Protective inserts and labels are added before the final shipment preparation, completing the high-volume production cycle. This aluminum radiator production line produces high-efficiency heat exchangers through a series of automated manufacturing stages. Raw aluminum tubes and fins are first inspected and fed into precision forming machines, where cutting and shaping operations ensure consistent dimensions and profiles. Servo controls and sensors maintain exact tolerances for each component before assembly begins. In the assembly station, fins are aligned and pressed between parallel tubes with controlled spacing to optimize airflow and heat transfer. Mechanical clamps hold the core structure while conveyors move the assembly into the brazing furnace. Inside the furnace, a controlled inert atmosphere and defined temperature profile cause the brazing alloy to melt and bond every fin-to-tube interface. This creates a unified, rigid core with leak-resistant joints. Trimmed cores then proceed to final assembly stations, where header plates, fittings, and seals are installed. Precision jigs and presses ensure alignment and proper sealing surfaces. Once assembled, each radiator undergoes a pressure test that fills the core with fluid and applies specified pressure to detect any leaks or weak joints. Sensors monitor pressure decay and automatically reject any unit that fails to meet standards. Radiators that pass inspection are labeled with part numbers and batch codes, then conveyed to the packing area. Protective materials are applied before boxing, completing the automated production cycle and preparing finished products for shipment. This cable shielding line from the machines applies overlapped metal shielding tape around cable cores for enhanced electrical performance. The process starts with aluminum tape unwinding stations, where two reels feed shielding material under controlled tension. Servo motors and tension sensors keep the tape taut and aligned as it enters the application head. Inside the shielding module, the tape is wrapped continuously around the moving cable core. A forming guide shapes the tape into a precise overlap pattern, while an adhesive applicator deposits bonding agent along the seam. This combination ensures a consistent, durable shield that maintains electrical continuity and mechanical integrity. The finished cable exits the application area with a uniform, snugly wrapped metal shield, ready for subsequent jacketing or finishing steps in the production line.